Hey everyone, today I will explain fractional indices as I have been told and requested. But before I start, I want to make out something important. In my video composite function part 2, in this specific example, it's positive 10, not negative 10, because 14 minus 4 it's 10. So it's positive, not negative. I wanted to make things clear and I wanted to apologize from you guys. I'm really sorry, but it's just a simple mistake. So let's start to talk about fractional indices. Okay, so before I start, I want to tell you the basic rules of the indices. So we have, when we have am multiplied by an, we add the powers together, m plus n. We do this only when we have same base. If the both numbers are the same, we will add the powers. And also when we have am divided by an, we subtract the power, also if we have the same base. And when we multiply, it's simple, m to the power a to the power m and to the power n again. It's only multiplying the powers together. And also we have when we have a negative, a minus m. A minus m, it's 1 over am. Why is this so? So a minus m, it's like a to the power 0 minus m. So when we have a subtraction, we divide. So it's a to the power 0 divided by am. And anything to the power 0, it's 1. So it's 1 over am. That's why a to the power negative m, it's 1 over am. Now I will start talking about the fractional indices. Okay, so now I will give an example. 16 to the power half. 16 to the power half can be written in this form, or 4 to the power 2 multiplied by the power of half. These are the same. Nothing are different between them. Now I will tell you how. 16 to the power half is square root of 16. When I have a fraction as an indices, when I have them as a fraction, I will take the below number and it will be the square root, cube root, whatever the number in the denominator is. Now if there is a number here, I will tell you what to do. Now I want to tell you how these are the same. Now 4 to the power 2 and also to the power half, the 2 and the 2 will be cancelled out. It's like multiplying 4, 2 multiplied by half. The 2's are cancelled out. We will have 4, and square root of 16 is also 4. So these are the same, whether you write 16 to the power half or 4 to the power 2 to the power half. This is the first example. I want to show you another one. So if I have a number like 1, 2, 5, 3 to the power 2. Wait. 1, 2, 5, 3 divided by 2. Now here I don't have 1. I have 3 divided by 2. So I can write 1, 2, 5 to the power 1 over 3, and it's all multiplied by 2. Wait, this is 2 over 3. Just let me do the same example. It's 2 over 3. So 125 to the power 1 over 3, it's all to the power of 2 also. So here, when we have two numbers, the number below, it will be the cube root, and then the number above will be the square. So the cube root of 125, it's 5 cubed. It's 5, sorry. Then to the power 2. So 5 to the power 2 will get 25. Okay? Now I want to tell you in general. Now in general, a to the power 1 divided by n, it's the square root, the cube root, or the fourth root, fifth root, whatever the value of n. And if we have a m over n, then it will be also the cube root, the square root, whatever the value of n, multiplied all to the power of n. This is the general form of what I did, of the two examples I did before. Okay, now I want to tell you how to solve these kind of equations. 32x equal to 2. Now the question here is find x. How to find the value of x? I want to do prime factorization for 32. So I'll put here 32. Now 32, it's the prime factorization. I want to start with the first prime number we have. It's 2. And yes, 32 divided by 2, we get 16. 16, it's also there in table 2. So again, it's 2. 2 8s are 16. Then 2 4s are 8. 2 2s are 4. And 2 1s are 2. So what we have here is 2 to the power 5. I have here 5 2s. 1, 2, 3, 4, 5. So 2 to the power 5 is equal 32. Now if I took the fifth root in both sides, here I will get 2 equal to. Now the fifth root of 32, I can write it as an indices, 32 to the power 1 over 5, right? And see what I've got. This one is exactly the same as this. So, therefore, the value of x is 1 over 5. We did the prime factorization for 32 to find the value of x. So 32 to the power 1 over 5 is equal to 2. Okay, I will give another example about the prime factorization. So we have 81x equal 3. We will do the same thing. We want to find the prime factorization of 81. If we started by 2, 81 divided by 2 will not give a real number or a number without decimals. So we will try by 3, and 3 multiplied by 27 is 81. 3 9s are 27. 3 3s are 9. 3 1s are 3. So here we have 1, 2, 3, 4. 4 3s. So it's 3 to the power 4 equal 81. We will take the fourth root, and the fourth root with the power of 4 will be cancelled. So we'll have 3 to the equal to fourth root of 81. So I can write this in another form, which is 81 to the power of 1 over 4. So x is equal 1 over 4. This is exactly the same as this. I hope this video was useful. Please like and subscribe for my channel and stay safe.